Thank you all for joining in. Please stay connected. We'll be starting in next 2-3 minutes. Welcome to all students and faculty from Father Concecio Rodriguez College of Engineering. Welcome you to Electric Vehicles, Your Opportunity to Grow, a webinar conducted by Rosefield Energy Tech in association with Udgam and ASME of Father Concecio Rodriguez College of Engineering. All of us are facing the impact of climate change, and even as it was discussed in COP26, many leaders have pledged to convert to zero emission vehicles by 2040. In fact, the transport sector is responsible for nearly 25% of energy related greenhouse gas emissions. So, climate change is inevitable, and we all need to do our part to fight against this climate change. So, transmitting to electric vehicles will play a major role in our fight against climate change. For doing this, we need to be aware about electric vehicle. We need to create awareness, understand how it works, and then become a part of this growing electric vehicles industry. Even as students, you'll have a lot of opportunities, be it mechanical or in electrical or computer science, any department, software, everyone will be participating in this electric vehicles journey, right? So you'll have a lot of opportunities as you'll see in this in today's webinar. where our speaker, Suhas Joshi, will take you through some fundamentals as well as trends and opportunities in electric vehicle. As Rosefield B2B, we are committed to create awareness for electric vehicles for more greener and sustainable future. In fact, our mission is to make everyone, whether it is students or professionals, employable or entrepreneur, through quality trainings on contemporary topics in energy and electric vehicle space. Through various service offerings like webinars, news, blogs, workshops, trainings, and much more, we are committed to electric vehicles and energy sector. So do log in and register to rosefieldb2b.com. It is free registration and you'll be able to access all these offerings. We have a LinkedIn group called EV and Battery Club where we post daily content, daily articles about various aspects of electric vehicles. So do join in the LinkedIn group as well. We had conducted a 2 weeks workshop on electric vehicles about few months back. We have now brought it to Rosefield B2B, where you'll have lifetime access to this electric vehicles program. This electric beginners to advanced training program on electric vehicles. There are about 8 sessions which talk about fundamentals of electric vehicles, market trends, battery management system, charging systems, so on and so forth. Once you register for and enroll into this course, you'll have lifetime access. You can access the videos anytime, so you'll be able to do self-paced learning. There are also quizzes and assignments to test your knowledge to ensure you are understanding the session. Also, after completing the course, you'll be getting a certificate of completion. So do log into rosefieldb2b.com today and enroll into the course. HPCL has always been a huge support to Rosefield Energy Tech. And today we have a message from Kushal Banerjee of HPCL. He'll be setting the context for today's event.
Dear all, good morning. I'm Kushal Banerjee, Chief General Manager, Business Development Corporate Strategy from Hindustan Petroleum Corporation Limited, Mumbai. And it gives me a great pleasure in talking to you all today on briefly about the Indian startup ecosystem and also the e-mobility sector, evolving sector in our country right now. Uh, Indian startup ecosystem, just to give you an overview, you must be aware that Indian ecosystem, startup system is the third largest in the world right now. In fact, we have got around 50,000 startups in our country. Around 9,000 of them are working in the field of technology. Around 1,300 in tech startups were born, in fact, in 2019 alone. And in fact, India has got around 100 unicorns and which are valued around $240 billion. And bulk of them, of course, are based in Bangalore, Maharashtra, and these geographies. Most of these unicorns are valued around 1 billion USD. And apart from the tech sectors, they're also working in the fields like pharmaceuticals, fintech, and agri sector. There are two areas, indicators of growth in the startup ecosystem. In fact, we have seen around 15% year-on-year growth since 2018 in the startup system here. And we have also seen the equal number of growth in number of incubators and accelerators, which is growing at the pace of around 11%. And significantly, the number of women entrepreneurs have grown by 14%. from 10% earlier. So we are seeing a lot of women entrepreneurs coming into the startup ecosystem. And the major contribution of the system you see is around 40,000 new jobs over the years being created. And this startup ecosystem is providing jobs to around 1.8 lakhs of people. So it's playing a huge role in our economy. And driver of the startup ecosystem is primarily, you can say, it's corporate connect and the government support. You must be aware that we have got a Startup India government department managed by DPIIT under Ministry of Commerce, and the big support is given to all the startups who can register here in this startup ecosystem. And we also, as regards us talking about HPCL startup ecosystem, in same in line with guidelines of Startup India, we have got our own startup ecosystem, which we call as Udgam. And as on date, we have got around 23, 24 startups getting incubated in under our Udgam scheme. And we have got online application portal where all the startups, young entrepreneurs can contribute. They can apply, and we, through our screening committee, we can pick those startups whosoever is found suitable, relevant to our sector, and we give them a huge support and backup and invest also selectively. We are working with startups who are something unique to offer in the field of AI, ML, sustainability, e-mobility, then your agri sectors, biofuels, all these areas we are supporting our startups. So I'm sure you young minds will have a lot of new ideas and new thoughts, and must be trying to put those into convert them into business opportunities. And all of you are welcome to join and work with the HPCL startup ecosystem, that is Utcom. As regards e-mobility is concerned, the Government of India is also similarly working on these initiatives, and they have started the National E-Mobility Mission, and we are working on this aspect. And a lot of initiatives and regulations have been brought forward. Like you must be aware of National E-Mobility Mission and the FAME 1, FAME 2 policies of government, where we are supporting, they are supporting around by way of giving grants of almost 18,000 crore in both these policies combined. And a lot of e-mobility and the system is evolving here. There's a lot of happening in Indian market. Also, you are hearing about Elon Musk starting Tesla in Bangalore, then Shell and PP getting into a charge system, and other OEMs like Maruti, your General Motors, they're gradually stopping the diesel vehicle supplies. So HPCL is also working very, very actively in this field of e-mobility and taken a lot of initiatives. We have set up charging stations in our retail outlets. Almost 52 has been commissioned, 22 are in progress. We are working together with other major players like ESL, NTPC, BHEL. And we are also setting up on the 9 express and the 16 highways charging stations, which can be used by the e-vehicles. We are working in the field of battery swapping. We have tied up with Voltup. We are working with major OEMs on battery swap stations. We are working with Ola Electric. And here also we are encouraging a lot of startups who are working in the field of e-mobility. We have tied up with our Magenta EV Solutions, which is our startup. We are tied up with Esmito, IIT Madras based startups. We are working with Virya Batteries on batteries, which is the IIT Mumbai based startup. So a lot of things are happening in HPCL, and R&D also we are working very closely. We are working on supercapacitors, then sodium ion metal sulfur batteries, advanced lithium ion batteries. Every activity is being taken up by HPCL in the field of e-mobility, and we are sure to contribute a great to environment cleanliness and climate control initiatives. So nice talking to you all, and we wish you the very best in your future endeavors. Thank you all for patient listening. Thank you.
Thank you, Kushal sir, for this message. I'll now invite Shailendra Gokhale, Director, Rosefield Energy Tech, to introduce our key speaker, Mr. Suhas Joshi, the EV expert.
I have a great pleasure now to introduce our keynote speaker for this event today, Mr. Suhas Joshi. I have been very fortunate to be associated with Suhas for the last couple of years. He is basically instrumentation engineer with a background in marketing management. He has over 34 years of experience in MNCs like Emerson's and Delta and Exicom. He has been extremely passionate about electric vehicles and battery, and you will very soon realize that how passionate he is about electric vehicles. He has actually deployed technologies in electric vehicles, battery management systems. So he comes with a very, very strong experience and not just the theoretical language. So without much ado, I would like to invite Mr. Suhas Joshi for making the presentation. Thank you.
Good afternoon, friends. Myself Suhas Joshi. I am going to take you through the very exciting journey of the electric vehicle. This is a great opportunity which is coming in India, and we are going to have a big boom in this market. If you see the total agenda, what I am going to cover in next 45 minutes to 1 hour is that the introduction, basic introduction, importance of the electric vehicles, which are the vehicles, types of electrical vehicles, charging system. When you actually work with the electrical system and electric vehicles, charging is very important aspect of the electric vehicle. So we are going to cover the charging also. Then the learning opportunity, which is most important for you, that what are the future opportunities which you will be having in this sector. And then followed by question and answer. So the brief introduction of my agenda, the first thing which we will be covering on the Rosefield introduction, transformation of fossil fuel to electric vehicles, how the transformation is happening and why it is happening. Then importance of the electric vehicle. Electric vehicle, the global penetration rates, the electric vehicles in India, how the electrical vehicles are going to be in India. Then India story, which will also cover why India actually needs these kind of electric vehicles. What are the challenges which India is having? So those aspects which I am going to cover in this form. Then types of electric vehicles, the different electric vehicles like two-wheelers, three-wheelers, buses, cars, and multi-purpose vehicles. Those vehicles, how they are important in our life and what are the systems which are there in this area. Then the learning opportunity of for the students for the future, what you are going to gain out of it. And learning components are many, like EV batteries which you can learn, how to do the EV maintenance, how the garages are going to change with the EV coming in, EV manufacturing, and the job and business opportunities what you will be having. This is the basic agenda, and this will be surely followed by the question and answer. So any doubts if you are having, which you can talk to me and I can give you best possible answers. Now coming to the global scenario, if you see the chart on the left hand side, you will find the electric vehicle penetration. What do you mean by electric vehicle penetration? When we talk out of 100 cars, if you see the Norway numbers, 74 cars are coming which are electric. The same scenario, if you see, overall Europe is really growing in this area, and you will find the maximum penetration in Europe. When it comes to China and United States, actually these are the two countries, those who are talking very much on these numbers of EV penetration. But numbers are there which are very low. Why? The main answer to this question, that vis-a-vis the total population of the vehicle, the number of vehicles which are electric are less. So this is what is the scenario as of now. If you see the future scenario, this is the scenario of 2020. If you go to the right hand side of the chart, you will find how the scenario is going to look like. currently in United States, the vehicles which are available, they are just 2 million. And by 2030, this vehicle numbers is going to grow to about 18 million. Similarly, Europe from 2 million to 28 million, and China from 4 million to 74 million. So this is what is the penetration rate which is going to change very rapidly. The number of vehicles are going to grow. So you can understand the opportunity which is coming in this arena. Most importantly, when I see this chart, I really feel very sorry. Why it is sorry? Because I don't see my own country. India is not appearing in this scenario at all. Why? So we need to understand why India is not appearing, and we also have to understand how we can bring India in this chart at much up in the ladder. This is most important thing for India. Now, when I come to the India as a story, the four aspects which we need to understand why electric vehicles are required. Electric vehicles are required. Traditionally, if I see, the electric vehicles was the history. If you see, before 1900, during that year, actually there were maximum number of electric vehicles were there. And in 1908, Ford introduced their new model. And when Ford introduced their new model, which was based on the fossil fuel, that got sold. So the sales of that vehicle started mainly because the vehicle was cheap, 1/3 of the cost. Second advantage of that vehicle at that time, there were no availability of electric vehicle charging infrastructure. And this scenario is now changing. The air pollution is increasing. The availability of electricity is no more a challenge in India. So, or even the globally, I am not talking only about the Indian scenario, but India also is not a challenge. So these aspects are now changing, and that is the reason electric mobility is going to grow like anything. Now, when I see the air quality in India, especially see if I talk about say Pune electric, if you see the air quality index which shows 156, and if I see the AQI chart, 156 is still coming under poor category or moderate category. Thane in Mumbai, India, it is 375, which is hazardous. Delhi, every year we hear in the month of November, December, January that these winter days actually the air quality index goes very bad. And then everyone starts talking about that this is a pollution which is happening because of vehicle and older vehicles. Actually, the study says that out of total pollution, 25% of the pollution in India is coming mainly because of usage of old vehicles. And these old vehicles, government has already brought in policy to scrapping the old vehicles. This is going to solve some sort of a problem. Apart from the air quality problem, there is another problem which is a noise pollution. So electric vehicles, when you will see, this is going to really help India in getting the noise pollution also down. When you go and stand on the main street, you will always find it's very difficult to even stand over there because of the noise pollution. But electric vehicles, less noise pollution is there. You will see when the vehicle is passing through in a nearby area, you will not find any kind of a noise which is coming. So this is one of the main reasons why India should go for electric vehicles. Crude impact. India every year imports practically $102 billion of USD worth of crude, and that crude is actually impacting our economic cycle. I put this slide just to give an impact to you that during the peak of pandemic, we always seen the clean skies. Why? Because at that time, all the industries were not working, hardly any vehicles were there on the street. So this has made the pollution very, very less. And when we go with electric vehicles, actually this kind of a money what we are spending on crude import, which can get reduced. I am not at all saying that this will go into a very lesser amount or it will not be there. The usage of the traditional fossil fuel is required, but it will go to a limited level. I also seen that the pollution, when we talk about many of the places like Delhi NCR, they have even banned the usage of diesel generators. Why? Because they generate the pollution. So, and they also use the crude oil. So, this kind of impacts actually making India to decide to go for electric vehicle. Now, when we see the sales of vehicles, the traditional vehicles, the total sale, when you can go and visit anytime the Siam site, you can find there are number of vehicles which are getting sold in India. So, what are the vehicles currently? If you see the total tabulation, out of total vehicles which are getting sold, 81% vehicles which are getting sold, which are two-wheelers. Then followed by the passenger vehicles like cars and other vehicles, then commercial vehicles, and then three-wheelers. So the main focus is actually two-wheelers, and Government of India has already announced that these two-wheelers beyond 2025, India is not going to allow to produce any sort of traditional vehicles. So production of the traditional vehicle is going to go away, and all these electric vehicles are going to come on the street or are going to get manufactured. So when you see 2 crore vehicles which are getting sold every year, the traditionally, if you see, when we talk about 2 crores of vehicles getting sold, means at any given point of time about 10 crore vehicles are there on the street. Generally the 5 years life, which I assume very roughly, but actually people they use more than 10 years, but still I considered the 10 crores of vehicles only. So I am going to talk after this slide that how the two-wheelers are going to impact. I am just taking as a short case study of two-wheeler so that you can understand the difference between the electric two-wheeler and the traditional two-wheeler. This is very important, because unless and until the common man who is using these vehicles like two-wheelers, whether it is a electric or it's a traditional, he should afford, he should understand why he is using, and he should be benefited out of it, without which this disruption is not going to take place. Now, most important part, whether government is supporting. Just now I told you that government is supporting by means of scrapping policy, but that is applicable mainly for four-wheelers and the commercial vehicles. Commercial vehicles beyond 15 years, now government has put a ban that they are not going to allow. Yesterday I read the newspaper, and one more announcement which has come, that after 15 years of usage, any government vehicle you cannot use. That registration is going to get cancelled even for the government vehicles. So this is going to become stringent. So if you see on the regulatory policy, CO2 emission standards, by 2022, India is going to implement those standards completely. Already you have seen in four-wheelers, there is a standard which has already come, and they are taking care of the four-wheelers. There is an incentive, the approved incentive, FAME2. This is a policy which India has announced, that 10,000 crores rupees are going to get distributed for the buyers, those who are buying the electric vehicles, so that government also will save the import on the fossil fuel, because today if you see a lot of hue and cry which is going on for the diesel and petroleum prices, so that will get impacted very badly, or that will be beneficial to us and the government. The target what government has put very clearly on the vehicle, by 2030, out of total vehicle sale, what we have seen, 30% of the vehicles will become electric. So this is a very big target. And when FAME2 subsidy, earlier before 2019 there was a FAME1, now in the second phase they have brought FAME2. FAME2 is applicable for 3 years, from 2019 to 2022. So government is very clear, they are driving this. And what they are driving? Generally, I have seen many of the cases, the two-wheelers which are there on the street, people they go to countries like China and they import the kit and they just assemble and they are selling it. Government is not going to support that. There is no kind of a subsidy which you are going to get. Government has declared a calendar well in advance that how you can get the subsidy, how the subsidy will be distributed. There is a calendar on every component what they are going to use, the manufacturers, the subsidy is defined on that. So this is very clean, clear-cut document. So what I'm saying, this is a high caliber market which is going to get available to India. Government is supporting, this is supported by all the numbers, pollution is going to get reduced. So what is the advantage? Why common man should buy or why he will not buy? This is a big question. So when I talk about EV, why EV? The common man, when I am talking about common man, EV is the future, which I always say the EV is the future. But why the EV should be the future? The energy efficiency of the vehicle, the electric vehicle, is practically 90 to 95%. And if you see the traditional vehicle, efficiency is just 17 to 21%. Now you will ask me, what is the efficiency of the vehicle? So when you use the typical gasoline or the IC engine, the efficiency when you are converting the fossil fuel energy into the mechanical energy and then to the electrical energy, actually it gives you a drop in efficiency. So electric vehicle, the efficiency is very, very high. Electric vehicles are more reliable. Why they are reliable? Because in traditional vehicle you will find 2000 plus moving parts. In electric vehicle, the moving parts are just 18 to 20. So practically it's a lot of reduction. I say always 100% reduction in the moving parts. So when there are lesser moving parts, the lesser chances of failure, lesser maintenance is required. So this is a dynamic change which we are going to face in the coming years. So we have to get accustomed with this change, and we have to get ready to accept this change, how we are going to work under this change and how this is going to get benefited. What customer needs actually? When I go as a common man, what I need from any supplier, when I go for a buying, whether it's an electric one or it's a traditional one, I don't care actually. Honestly speaking, I don't care. Unless and until people they go and say, no, these are the advantages and all. But we always consider as a common man that these are the sales pitches which we get. When we see in terms of electric vehicle, what is the price? Whether it will be expensive, this is a new technology, whether there is a roadside assistant, if the vehicle fails, who is going to support, what is the warranty, whether this is a new technology, new vehicle which is coming, whether it is going to really help me, or after 6 months whether that company will get closed down and where it will go, I don't know. Whether these electric vehicles, how to get charged, whether I can charge it at home, whether I have to go outside, how much time it is going to take, this is very, very important for me to understand as a common person. Mileage, whenever we see, I always see in all the traditional vehicles or even the automotive ads, people they are very, very conscious about the mileage. So though it is an electric vehicle, the mileage is also very important. So what is the mileage in terms of electric vehicle? Mileage means vehicle will go in one charge, how much kilometers it will travel. This is the simple calculation. So this calculation can give you the per kilometer cost of the vehicle. Now I am making a comparison. Just I have taken two-wheeler as a benchmark. If I see, just go through it very, very minutely, very important topic. When I see the traditional scooter, you go any best benchmark scooter in India, that cost you roughly about 75,000 on road or whatever. I am just assuming a price of 75,000. In 1 liter petrol, which is now coming to the cost of about 100 rupees, it goes about 35 kilometers on an average. So practically I am spending 3 rupees for traveling 1 kilometer of mileage. This is very, very important. So if I consider in the whole life cycle of my vehicle, I travel about 1 lakh kilometer, 100,000 kilometers. So 3 into 1 lakh. So this is coming about 3 lakh rupees. So the total ownership cost for me for 3 years of running a vehicle is about 3,75,000 rupees. And this is generally used by a common man. Now, when I come to electric scooter, what is the difference? I assume the scooter, I have not assumed the bike, because bike the parameters are going to change. So I am making it very, very clear, because the comparison also has to be apple to apple. Buying price currently, if you go for any reputed brand of electric two-wheeler, it costs you about 75 rupees. And generally in one charge, it goes about 70 kilometers. So when I talk about 70 kilometers, how much money which I need to spend to recharge this battery? When I recharge this battery, it costs me about 1.3 units. Means practically the home usage, if you charge the battery at home, it is coming about 8 rupees to 9 rupees depending on the state in which you are charging. I still assume 10 rupees on the higher side. So per charge, it is going to cost me about 13 rupees. So 13 rupees divided by 70 kilometer. Per kilometer, my running cost is coming just 18 paise. 18 paise per kilometer. So this is a difference. 3 rupees per kilometer of traditional vehicle vis-a-vis 18 paise per kilometer of electric vehicle. That is a very, very powerful example. Now you will ask, battery is a very important part in this vehicle, correct? So when we talk about battery, I assume that in electric two-wheeler, I replace the battery after say 50,000 kilometer, and I assume the battery cost of about 25,000 rupees, because the battery prices traditionally are coming down substantially. So the cost of replacement of battery plus 18,000 rupees of driving 1 lakh kilometer as a fuel cost, the total cost of ownership 25,000 rupees plus 18,000 rupees plus 75,000 rupees. The total mathematics is coming about 1,18,000 rupees. So 1,18,000 rupees vis-a-vis 3,75,000 rupees. This is a very big disruptive kind of a calculation where the common man will jump. If you can see a common man who is traveling, the people like us, those who are traveling approximately say 500 kilometer in a month, actually this is a very big value proposition to him. He can save lot of money. He can save lot of money. So this is very important calculation, and this can impact his pocket substantially. So one has to be very, very careful when we go for electric vehicle. What are the advantages as a common man? Now, I have not spoken anything about the maintenance cost. If you see the traditional vehicle, the engine, always we talk about CC of engine, and there is a oil management, oil filter has to be changed. When it goes for actually the maintenance, the garage fellow will always tell you, I have changed the oil, I have changed the oil pump, I have changed this kind of a washer, I have changed the cylinder head. So number of items which are there. So the management or the maintenance of this vehicle is very, very clumsy. If I compare this vis-a-vis your electric scooter. In electric scooter, if you see, there are very simple minor components. One is the powertrain, there is a motor, motor controller and battery. These are the three very important components. Very simplified version, and these components are again connected. They are connected by the communication. So this vehicle actually getting connected on the internet, intranet, all kind of facilities which you can actually work on this. So there is a communication facility. So practically, as the number of components are getting reduced, the reliability of these components, like motor which is very rugged vis-a-vis the engine, the efficiency wise also and the moving component wise also. The electronics is there in the battery, so battery maintenance is negligible and battery lives are very long. I am going to discuss battery as a individual component, because I want to tell you the complete reality of this. This is not a forum in which I am going to come and tell or sell any kind of a vehicle or any kind of a technology. What I am trying to bring the differences between the two technologies. So this is what I am talking about, the overall vehicle. When you talk about the key component, motor, which I just now I said, so number of types of motor, like the hub motor, BLDC motor, number of motors which are there, motor controllers, depending on the vehicle. the vehicles which I have seen, people they call it the low speed, high speed. So motor calculations are very very important, and the applications by which you get connected, the motor controller is very very important. So these are the two important components of the electric vehicle. Now coming to the core part, battery. Battery is practically it's a 50% of the vehicle cost. So which type of a battery which you have to select is very very important. Traditionally, the people they used to use, if you see on the right hand side of my chart, there is a chart which is given by ESA. This is an international company wherein they always talk about the technologies, what are the better technologies, what are the poor technologies. So lead acid batteries, then the lithium ion energy cells, then lithium ion battery, the power cells. Now you will ask me the question, you are talking about lithium ion, but in lithium ion batteries itself there are multiple chemistries, and chemistries are changing. If you see the chart, the life cycle. Why life cycle is important? Life cycle is important because the number of life cycle means number of kilometers which you are going to drive. One life cycle, one cycle life means one charge and one discharge. So if I am talking about say 70 kilometers of vehicle is going to charge, then if my vehicle is giving say 4000 cycles, means 4000 into 70, that much of life this battery is going to give. Still I have considered 50,000 I am going to change, but actually in reality you will get much more life. No need of changing the batteries in the vehicle. So this is the importance. And on the second, on the x-axis and the y-axis I have put the cost also. So lead acid batteries, traditionally in the electric vehicles, the two-wheelers, people are still selling the lead acid batteries. Lead acid batteries are having the lesser life, and they are also having the charging challenges. These lithium ion batteries get charged in a very short span of time. Lead acid batteries take about 8 to 10 hours to charge the batteries, and their discharge curves are very very different. Now why battery is important? Again, the best cell design. There in the construction wise also, in the battery there are number of patterns, like I mentioned about the cylindrical cell, the small pencil cell kind of a cells which you will find. These cells are used in generally in two-wheeler. So those cells are used in building up the battery packs. Prismatic cells, when you go for the bigger battery packs, like you go for say the car batteries or the truck batteries, those prismatic cells are used. Then the pouch cells, which are lightweight and they are used in again multiple applications. So this is what is the way battery definition or the battery defined is required. Now we are going to talk about battery pack. Why battery packs are important? Battery pack is the most important component in the electric vehicle. As I told you that battery is 50% cost of the vehicle. So when we are making a battery pack, there are number of aspects which we need to understand. If you see, as I told you that we use generally for say two-wheeler battery pack, this is a typical picture of two-wheeler battery pack. What are the components which are there? Battery cells, battery cell holder, battery container, that is a cabinet, then the BMS, and then the electric terminal. So when we use the cylindrical cell, generally these packs for say two-wheeler, generally the pack size is roughly about 1.5 kilowatt to 2 kilowatt at 48 volts. So every individual cell, if you see, either it is 2.3 Ah and 2.8 volt cell. So what we do, we combine those cells, number of cells, and we make a pack of this much of voltage and this much of Ah. So that generates the energy. When we are doing this pack, the important aspect is that how to connect this kind of a cells, because these are number of cells which we are going to use. So the challenge is another, that how you are connecting these cells, which type of welding technology which you are using, which type of cell holders which you are using. Why I am talking about welding technology? Because the two-wheeler on the street, when you are driving, actually the road conditions, are very important. It should not happen the joint of the cells, if it is weak, then the pack is going to fail, and if the pack fails, the vehicle fails. And when pack cost is 50%, you have to replace practically the pack. So this is very important. So welding technology is one of the most important factor in this segment. Then the battery management system. We are talking about say 100, 200, 300 cells and we are making a pack. So when you are making and doing the coordination of this 200, 300 cells, what is important? That there has to be someone who can manage these cells and they should do the coordination of these cells. So battery management system, we call it as a BMS, it actually does this function. This is very important for the battery pack performance. And this is actually a heart of the battery pack. Then the battery container. Why battery container is important? Again, the Indian road conditions, when you are traveling it on the road, you should understand what is the road condition, on which road this vehicle is going to run. The important aspects, these cells are not manufactured in India. As of now, these cells are not manufactured in India. They are coming either from China, Korea, Japan or Europe. And generally these packs which are manufactured over there, these cells are tuned to work in 10 degree to 25 degree of temperature. But in India, the temperature is very different. So you need to give actually the proper environment so that cells will not get impacted. If you see, say, northern part of India, in summer, practically the ambient temperature is about 47, 48 degree. So inside the pack, temperature may be 55, 60 degree. So in that condition, if pack has to work, there has to be some cooling system. In Europe and US, which I have seen, they also give the battery cooling system. But actually that is not a cooling system. They give this system is used as a battery heating system, because in Europe and US, the temperatures are sub-zero temperatures. So in sub-zero temperatures, the chemical reaction won't take place in the battery cell and cell cannot perform. So they actually heat the cell. But in our case, it's exactly reverse. So you need to really understand this. Again, the level of charging, at what level it has to be charged, what level it has to be discharged, at what current it should charge, in how much time it has to charge. It depends on the every cell, because you have seen in the earlier slide, there are number of type of chemistries and they are defined according to the charge discharge cycle, then your cyclic life. So temperature and the charging discharging, these are one of the important factors. Another important factor is the communication. Why communication is important? When you are traveling on the electric vehicle, your battery is getting discharged. Who is going to tell you battery is discharged? Or suddenly the vehicle will halt. So to avoid that, there is a communication from the battery pack to the basic desk or the basic indicator of the two-wheeler or any vehicle. So it can give you the complete level of battery at charge, how much charge is remaining. So like you are going from one place to another, whether what is the distance, how much distance I can cover with the current battery charge, you can easily understand it. So this is very important aspect. So that is what I want to mention very clearly, that battery pack is most important in the electric industry, electric vehicle industry, and it has to be made properly. I want to give you more emphasis on the battery management system. As I told you, the battery management system is a heart. So we always say a heart attack. So battery management system is like a heart of the overall electric vehicle. So there are number of aspects. It can protect the vehicle or it can protect the battery pack. Current voltage protections it gives, thermal management, like when the temperature is going inside the cell which is going high, then it can cut the battery. Then intelligent cell balancing, like number of cells which you are using, so keep the proper balance of that. Health monitoring, if some of the cells are going weak, then it will inform you that few of the cells are going bad, so the battery pack health is going to get deteriorated. So it can tell you those things. Then another important aspect is isolation fault detection, advanced isolation fault detection, which we say. It always give you that yes, there is a fault which is coming and it is detecting that advanced fault. Then the software for data logging, like when you go and buy a two-wheeler, what you will say? Two-wheeler or any electric vehicle, what you will say? That how much is the battery life? The vendor will tell you that okay, I am giving you, the manufacturer will tell you I am giving you 3 years warranty. But 3 years warranty, but what is the life? So always the battery life is determined by means of cyclic life. How many charge and how many discharge cycles. So I will tell you that my battery pack is giving 5000 cycles. How you will prove it? But there is a software in the BMS which is written, which always counts that how many cycles of charge, how many discharge cycles are already happened. So when you connect the battery pack, you will come to know that how many charge and discharge cycles are already over. So you can predict the life also. Another important factor, which is a battery sleep mode. You have sold the battery pack, you have sold the vehicle, but you are not used. This is what is a very big problem which I have always seen in the lead acid batteries. So this kind of a problems, this battery management system can take care, and it can give you a very good performance in the longer run. So this is very, very vital. Another important aspects which I was talking about is a communication and telematics. So generally these battery packs in EV industry, they follow the CAN bus as a protocol by which they keep on communicating. So you can have a typical kind of a mobile application. On your mobile application, you can see whether my battery is discharged or it is charged. So when you are going, you can easily calculate that whether I'm traveling from one location to another location, whether I need to charge my battery in between or not. So those kind of things are available. Then the theft management, you can control the battery pack from remote. So actually the vehicle can be controlled. So there is a geofencing facility. So no one can take out the battery and take it. You can remotely you can switch off the battery. So those kind of functions are available. So battery can become a kind of a IoT platform. So in the vehicle is actually going to come on the IoT platform. Most important factor beyond the communication is EV charging. So EV charging for the scooters, I have put a few of the pictures. So there are number of chargers. So these charger itself is a very big industry which is going to come up. And I'm going to discuss at length what kind of chargers which are used, what are the protocols, what are the ways and means it is working. So along with the vehicle, always you get a battery charger, which is a mandatory thing for any seller. Now coming to the battery charging station for EV. Now I am taking you out from two-wheeler industry, because two-wheeler, the battery charging is not that difficult. You can go and charge the battery at home. Even now the situation has come that say 75,000 rupees vehicle, you don't buy the battery. And battery swapping system means what? As like you go and fuel your vehicle, you will find number of battery swapping stations wherein you don't buy the battery along with the vehicle. You buy the vehicle say at about 40,000 rupees and take the battery on rent or swap the battery. So you use the battery. When the battery is getting discharged, go to the nearest petrol pump or the nearest swapping station and replace the battery. So you can be saved like that. If you see in China, Europe, US, this kind of a number of charging stations which are available. And this charging station is coming out to be a very huge business. Why it is a huge business? Because there are different charging systems. Why different charging systems? Mobile charging station. What are mobile charging station? Actually you can carry or you can take the charging station near to your vehicle. Like this kind of services which are given in many of the locations in US and Europe. Because your vehicle is stuck on the street and because the battery is discharged. So someone will come along with the charger and the battery pack. He will charge it and then you can go. Residential charging. When you travel the vehicle, I am talking now about four-wheeler, just come out of the two-wheeler, I am talking about four-wheeler. You have traveled the vehicle through a vehicle for about 100-200 kilometers. Generally the range for four-wheeler is about 150 kilometers to 300 kilometers per single charge. And you travel throughout the day and in the evening you can charge it at your home and at your residence. When you are traveling on the highways, you can go for fast charging, public charging station. So there fast charging chargers are available. In residential charging, you charge it at very low rate. So charging time is high and you are not bothered in the evening. But when you are traveling, say from Mumbai to Pune, what you will do? In between, when you need to charge the vehicle, you need a fast charging. So fast charging is also possible. What is the type of charging and all? I am going to discuss at length. Now just look at this picture, very important picture. Here I am talking about the typical charging levels. So typically a car which you will see, there is an onboard charger which is given by a manufacturer. So this is a low charger, like say typically if I consider say 20 kilowatt hour of battery, and then the charging which is going to happen on the onboard charger is about 3 to 4 kilowatt. So on the right hand side there is a L1 charging, L2 charging and DC fast charging. These are the different levels. So the level of charging L1 and L2, which is generally a home charging or the public charging for the slow speed charger. But when you go on the highways, you need a fast charging, which is typically between say 30 minutes to 2 hours. So there DC fast chargers are used. So the rating of those chargers is coming from 15 kilowatt to 100 kilowatt or 200 kilowatt. So this is kind of a charging which happens. And if you see, the fast charging is good, but as well as it is bad, because when you are charging the battery at faster rate, the life of the battery you are compromising. So one has to really understand what kind of a discharge or charge, how it has to be taken place. So this is the most important factor. Now another opportunity which comes, like when you go on the charging station, no need to go and there will not be anybody. These are all unmanned charging stations. If you have seen my earlier slides, I mentioned very clearly, these are all unmanned charging stations. So on these unmanned charging stations, what happens? You go, there is an application which you download, you simply go and put the application, you authorize the charging, you put the connector and you start charging. When you start charging, this is a similar applications wherein you can always charge by means of money. Like I want to charge for 100 rupees, I want to charge for 2 hours. So those options are generally given. And then you can select it on your mobile app, you can pay online and the charging happens. There is a protocol called OCPP. This is a global protocol which is mentioned and this is run globally. So this is a very standard protocol. And CMS, that is the central monitoring system. So all kind of a chargers, suppose I am a charge zone operator, then I will have number of chargers distributed all across the country, and these chargers I will manage it from single location. So no need of any manpower for that. So these systems again are getting actually a automated one. Now coming to the charging standards. So when I talk about the DC chargers, there are multiple standards. So if you see on the left hand side, there are 3 standards, CCS 1 and 2. This is a combo charger which is typically used in Europe, GB/T which is used in China, and CHAdeMO which is used in actually the Japanese car makers. So this is the 3 charging standards which are available. You cannot change it as of now. India is focusing more. Traditionally India started with GB/T, but now India is focusing on CCS 1 and 2. So we have to keep it in mind, CCS 1 and 2 as a standard. In this standard, which is very clear, if you see the connector, the picture of connector which I have shown in the slide, this is not only giving and providing the DC power, but it also communicates with the battery management system of the vehicle. So when you connect the charger, actually when you put this connector to charging, this connector can communicate with the battery management system of your vehicle, that at what voltage I have to charge, at what rate I have to charge, every communication which happens, and then it decides that this is the rate I am accepting it, and then the charging starts. Similarly, globally accepted AC charging for type 1 and type 2, in the earlier chart we have seen the sockets are different. So those sockets are again different for AC charging. So I am not getting into the nitty-gritties at this moment. Now coming to the current scenario, how currently the charging is happening. The traditional vehicles are getting fueled. If you see totally in the country, there are about 63,000 filling stations or the petrol pumps. And how many vehicles? 6 million plus 20 million plus 5 million plus 80 million. More than 110 million kind of a vehicle. So those many vehicles are getting fueled at 63,000 petrol stations, where the filling time is just 5 minutes. Why I am bringing this topic? because we have to see how this business is going to grow. Because in electric vehicle, charging is minimum time is, even when we call about the fast charging, the timing is more than an hour. So multiple charging systems are going to be, potential will be much more than the filling stations. Just for your calculations, I have put some kind of a numbers. Like for electric bus, on an average battery will be 100 kilowatt, car will be 30 kilowatt, and rickshaws will be say about 3 kilowatt, and two-wheeler will be about 1.5 kilowatt. So what is the total energy is required? This is again an aspect. Fortunately, India is now focusing very largely on the solar. So the energy which is going to come on the solar, and if this many vehicles, if I see how many gigawatt hour of power which is going to required. So this is an food for thought, and this many vehicles to charge and discharge every day and day out. What are the challenges and what are the opportunities? There are challenges, but there are opportunities. So yeah, you will see this many charging stations are going to come in the coming days. Now, if you see the another advantage which is going to have when I am talking about this many vehicles, this much of power, actually if you see down below chart which I have shown on left hand side, I have mentioned very clearly the solar power which will be used, and the grid. So there has to be a charger, always has to communicate with the grid also, because this many discharging or charging vehicles are going to make the grid unstable. So this is a scenario which is going to be a very complicated, but opportunity is there for many engineers to work on this. The advantage of these vehicles, every vehicle is not going to be charged throughout the day. So the complete vehicles are not going to be charged, but there are batteries. So huge energy flow which is going to be there on the streets. So when my grid is getting unstable, actually the communication between vehicle to grid, if it is happening, then actually I can use that battery energy which is available in the vehicle for stabilizing my grid. So at that time, a consumer who is actually using this battery in your vehicle is going to support the grid. So you will get paid for that. So those kind of a protocols and that kind of a future which is going to come. I am just trying to make a point, nothing beyond that point. Now coming to the onboard chargers. So we discussed the charger depending on the battery, how much is the charging required. So number of ancillary components which are going to come up, like DC-DC converter, onboard charger, power distribution unit. Why power distribution unit is required? And what is the DC-DC converter usage? You will be having the lights inside the vehicle, you will be having the air conditioning inside the vehicle. So those kind of the power distribution has to be there inside the vehicle also. So for which there is a common unit also which comes, individual units are also coming. So power electronics unit, which is a combination of DC-DC converter, onboard charger, power distribution unit and motor control unit. So this is the ancillary units which are going to come up. I just now said about the DC-DC converters, what are the advantages, number of ratings. Again, these vehicles are coming with the different voltages. There is no standardization as of now. So from 200 volts to 750 volt, multiple ratings are going to come. So how this has to be taken care, how it has to be managed and how it has to be used, how the selection has to be done. Now, what are the opportunities? The most important part of this presentation, what are the opportunities for you as engineers and as the management students? What are the opportunities which are going to come? We have to really accept the opportunities which are coming. Transition is going to take place from the automotive engineers to mechanical engineers and to the electronics engineers plus software engineers. Now, what are the opportunities for mechanical and electrical engineers? See, I am not talking anything about the automobile engineers. Why? Because the situation is changing. The situation is going to change rapidly in the EV adoption, because no engine, no oil, nothing is going to be there, and it will be all electric. So mechanical engineers, where they will be utilized, they will be making the vehicle bodies, different types of motors, different types of motor controller, ancillaries, battery, EV charger, battery pack unit, DC-DC converters and the welding technology, which is very, very important. electronics and software engineers. Now, there was no role actually for these people into the automotive industry. But now, the battery management system, lot of algorithms you need to write, lot of software is important. Battery communication is becoming very important because batteries or the vehicle are coming on the typically on the platform wherein you can manage it from the remote location. Mobile applications, geofencing techniques, remote management of vehicle. So when you manage the vehicles from remotely, now everyone is talking in Europe the driverless cars. So when you see the battery management system applications and the algorithms which are written for the running the cars and vehicles, those days are not actually very long having a driverless vehicles. Algorithms for BMS is very, very important. Charging communication, vehicle communication. So actually the scenario is going to change from automobile engineer to mechanical, electronics and software engineer. So these many kind of things are going to change. Now transformation of the industry, how it is going to happen? When we typically talk today, typical mechanical and automobile, mechanical engineers used to talk or the automobile engineers typically used to talk about CC and HP of the engine. What is the vehicle which you have purchased? I have purchased 1000 cc vehicle. I have purchased 2000 cc vehicle. Now this is going to change into the kV and kilowatt hours of motor and battery. So what is the battery size? What is the charging time? What is the petrol, diesel and CNG will get converted into the charging connector, whether it's a CCS vehicle or it's a CHAdeMO vehicle. Per liter mileage to per charge mileage. So this is a transformation, the words, the juggleries which are going to happen, which is going to change. No more you are going to go on the petrol pump, you are going to charging station. And no need even many of the times you no need to go to even charging station, you can charge the vehicle at your home. So this is a transformation which is going to take place. So for Rosefield, what are the models which we are going to bring it to you for learning? Typically, I am telling you, we are a company which is a professional company. We are not interested in telling you on the technologies alone because technologies are taught well in the colleges and we cannot touch that. But we are coming with the professional experience. So what we are going to cover you up in the applications, opportunities, government policies, in the framework, what are the best things which you can do and how you can manage these things in the longer run for the benefit and the long-term career. So this is what is the theme with which we are coming. We want the young engineers should get ready for future. It should not happen that we are reactive. We have to be proactive. Still this journey has just started. Journey has not yet started. Journey is going to start. So we should get ready. So there will not be any dearth of potential for the jobs, for the businesses. There is no dearth because the industry is going to go with the very big change. So we are very clear what we are going to try and talk about. So few of the models and we are very open for customizing this module. This is not that this is a module and this is, and there are another I have seen there are about 40 to 50 associated business which are coming up. So we are having a huge knowledge, but we want to take it to the youngsters so they can understand this and they can really make use of it. So the basic program we cover the basics of electric vehicle, how the electric vehicles are different, just now which I have spoken many things about it. So core opportunities, what are the opportunities which you are having, types of batteries. So this is typically about 40 to 45 hours of learning which you can go. This is possible with the basic learning course. When you go with the say electric bicycles, now I am coming to the product specific. Why product specific training? Because unless and until someone will have the interest in going ahead with the manufacturing or the manufacturer of electric vehicles, say in the cycle space. So there is no need for him to learn the other things. He should understand the nitty-gritties of the bicycle very completely. So what is the powertrain which is used for the battery cycles, type of motors, then the motor controller, what is the type of motor controller which is used. See, when we go and buy the cycle today, there is no need for going for any approvals. But these electric cycles need to be tested and getting to be certified from the government agencies, any electric vehicle. So this is most important. Like how much is the gradient on which you are going to go. So that also decides the motor rating. That also decides the battery rating because battery discharge or charge cycles are dependent on that. So learning in depth will help you in understanding all the nitty-gritties. So this is what is the program for say electric bicycle. Now we are going to talk about the electric scooters. What are the things which we are going to cover in electric scooter? As we discussed on the electric scooters, high speed, low speed scooters. What do you mean by low speed scooters? So low speed scooters are generally used for the speed limit which is less than 25 kilometers per hour. And these scooters today, they don't need any kind of a license or registration or insurance to drive this vehicle. So this is what is a very important aspect. And if you see today on the street, number of low speed vehicles are visible. But when it comes to the high speed, actually the speed which is more than 25 kilometer, which is a tune of say 45 kilometer per hour, that kind of a speed where you need to go for the high speed vehicle. And these high speed vehicles are very different, wherein you need to go ahead with the approval with ARAI and ICAT. These are most important things, and there is a process which you need to follow to go for those approvals. So the types of motors which are used for these vehicles are different. For the high speed and the low speed, the gradient where in which you are going or taking the scooter on the hill area, in the hill area, then the vehicle motor will be different. Types of motor and motor controllers are different again in this vis-a-vis your other vehicles. Type of batteries are different, chargers are different. General specification, what we tell you about this kind of a vehicles. Then the telematics which is required, what are the telematics which is required. Then maintenance of electric scooters. As I told you, the vehicle maintenance is going to change. There is no need for going and taking the vehicle to the garage unless and until there is a mechanical problem. These vehicles can be taken control from the remote location and you can manage this vehicle. So garage theme is going to get changed over here. Government directives, as I said, the ARA and current laws which are there. Currently the subsidy which is available, that also is a topic by itself. For getting that subsidy, what are the things which you need to do. So it's a kind of a 25 hours of learning we take you through, and we make you understand completely. Three-wheelers, if you have seen, this is the first vehicle which has come in the market in India. More than 15 lakh vehicle or 1.5 million vehicles are already on the street, and every year about 1 lakh vehicles are getting added. If you go to Delhi NCR area or northern area in the country, you will find number of vehicles for the last mile connectivity. Even the electric rickshaws and the loaders are there for distribution of milk, for distribution of vegetables. The electric loaders are used. Many of the government associations like Gram Panchayats and all, they are using the garbage collection vehicles for as a loader, which are electric one. So this again a very different application. So types of motors which are used for this kind of a vehicle. Then the similar thing what we discuss about telematics, maintenance, government laws and subsidy. So this is again a learning. We are coming to the electric car. Electric car is a very different topic. Again, we talk about all type of electric vehicles like a battery electric vehicle. Then we talk about the plug hybrid electric vehicle. Those kind of different types of vehicles which are available. Then we talk about motors which are used for this, because in two-wheelers and three-wheelers, motors used are typically BLDC motors, and here you can use the induction motors also. So motor controllers are different. The BMS which is used in this kind of a vehicle is very different. This needs and compliances like IS 26262 kind of a compliance which is mandatory for cars and the bigger vehicles. So what are those compliances? What is onboard charger which is required? Charging connectors again, which is a very important thing. How the charging happens, how the communication happens, communication under central monitoring system, what is the battery charging methodology which is used, telematics required for the car is different than the two-wheelers, then the government directives and the current laws. So is a kind of a complete 50 hours learning which we can take you through in this area. Similarly, for the commercial vehicles, again a huge opportunity which is coming up for electric bus and truck. So if you see those kind of vehicles wherein we are talking about, we have tried to make it a common platform for learning. So these are the typical modules which we have put. We can customize the module as per your requirement. We can take only as a motor as a module, which are for all the electric vehicles. We can take battery as a module, because battery, there is a huge learning in battery itself. Charging as a module, which we can take it. We can take telematics or the communication as a module, which are very, very different modules which we can customize. We have got those capabilities, experience, and the database also which we are having. We are also trying to, when we are trying to customize this, what we want from you, the clean, clear-cut feedback. We already circulated you few of the Google Forms are already available. We have already provided the link. What we want, what do you really want to understand, and what do you really want to learn? We have got abundant knowledge and experience available. We want how much you can snatch and how you can grow. Our intention is to make you learn and learn out of our experience, so that our country can grow. So please fill up those forms. If any information is lacking in this, you can go on our website. We have also given the email address, so you can go through it and you can give your feedback. Thank you very much from my side. Thanks.
Thank you, Suhas sir, for this excellent presentation on electric vehicles. As mentioned by sir, we have put the Google Form links for the feedback form in the chat box. Please fill the feedback form. Please note, people who have registered, attended the event, and filled the feedback form will only receive the certificate of completion, or certificate of participation for the event. Like I previously mentioned, we have recently launched a course, Beginners to Advanced Training Program on Electric Vehicles, which is a detailed course on fundamentals of electric vehicles, including types of electric vehicles, components, battery, types of battery chemistries, battery charging system, vehicle charging systems, swapping systems, battery management systems, so on and so forth. It is a LMS kind of platform, so you'll be able to have lifetime access and you can access the videos anytime on your enrollment. There are also quizzes and assignments to enhance your knowledge. And on completion of the course, you'll get a certificate of completion. So do visit and register Rosefield B2B now and enroll into the course. If you have any questions regarding today's event, you can write to us at info@rosefieldb2b.com. I now take this opportunity to give a formal vote of thanks. First of all, thank you to Father Consicio Rodriguez, College of Engineering, and ASME for organizing this event. A big thank you to Professor Deepika Singh Gror, Madam, who is the ASME Council in charge. Also, thank you to the council members and students at ASME for their support in organizing this event. A special thank you to Kaviraj Ishwaran. HPCL has always been a big support to Rosefield, and big thank you to them for setting the context for the event and supporting this event. Thank you to my team at Rosefield, Director Sharindra Gokhale, CEO Bhaskaran Nagarajan, Prasad Zadav, Vas Sarvankar, Varad Taraf, and myself, CFO Kasturi Bhavle. Once again, a big thank you to all the participants for joining in huge numbers. If you have any queries regarding the webinars, we have a lot of upcoming webinars. We recently concluded a webinar on charging stations. We are now coming up with another webinar on safety of EVs. If you have any suggestions regarding or topics regarding which you would like us to conduct more events, please write to us. You can include that in the feedback form. Also, you can share in the chat box how you felt about your thoughts about this particular event, we'll be happy to share that. Thank you, everyone, for participating today and joining in this session. We are signing off now. Have a nice day. Thank you.
Ma'am, just a minute. Can I please say a vote of thanks?
Yes, Kaviraj?
Can I please say a vote of thanks?
Yes, please.
On behalf of the entire ASMA Council, I would like to take this opportunity to thank Subhash Joshi sir, Shailendra Gokhale sir, Bharat sir, and Kasturi ma'am for taking out time and enlightening us with their knowledge. We are extremely honored and grateful to you for providing us with great insights and presenting this knowledgeable session. I would like to thank Professor Deepika Singh Singhal for providing us with immense support to make this webinar successful. I must thank the entire ASMA Council for their hard work and determination to make this webinar a huge success. Last but not the least, I express my gratitude to all the participants attending this webinar. Thank you, Vanan.
Thank you, Kaviraj.
Thank you.
Participants, we request you once again to fill the feedback form, which is through the link given in the chat. We'll keep the meeting live for next 2 minutes so that you can access the link. We'll then log out.